Hello everyone. Today we are going to learn how to measure the gravitational acceleration using the software called the tracker. So this tracker can analyze the physical quantity of the motion that you record using your handphone. So I already opened the tracker software. It looks like this. And also I have prepared the video of free falling motion. And also this is the Microsoft Excel where I copy paste the data from the tracker to this Microsoft Excel. So we will process the data here and get the graph and get the gravitational acceleration from the gradient. So let us import the video of free falling motion. So this is my video. The format is MP4. Click OK, and the first thing that we have to do is the calibration of XY axis, and we put the free falling motion in the area of X positive and Y negative, special case for free falling motion. And the next thing that we have to do is the calibration stick. Click this logo and choose new and calibration stick. And we have ruler over here. This ruler is 50 centimeters. So we do the calibration towards this ruler. There is instruction, press shift button and click. So zoom in and click in the end of the ruler, which is 0 centimeter. And also in 50 centimeter. Make sure that the value is 0.5. 0.5 meter means 50 centimeter. And then we adjust the position of the video frame. Make sure that the first frame is the frame where the ball is starting to fall down. Okay, I think this frame, yeah. And also adjust again the position of the calibration stick. Make sure that it touches 50 and also 0. Okay, I think we are done. Okay, we are ready to do the tracking toward the motion of this free fall. Click create and click point mesh. And we are going to get the data of the velocity versus time, because the graph will be time versus velocity to get the gradient and to get the gravitational acceleration. So we adjust this y-axis. So this is not x, but this is Vy. And also for this one, for this table, we only get Vy versus time. So Vy and so time. Okay, we are ready to do the tracking. Make sure that the track control over here is active. Now press shift button and click at the center of the tennis ball and follow the motion of the ball. Make sure that you click the center of the ball. Click again the center of the ball. Okay, I think this one is the last one. Okay, we are done. Okay, this is our data, time and also velocity in y-axis. So we copy this data to Microsoft Excel. Just select the data that we need. Right click, copy selected cells as formatted. And go to Microsoft Excel. And we paste over here. We move this time data to here. Okay, I repeat. And also this data to trial 1. So to get the data for trial 2, we use the same video and we use the same position of X and Y axis. And also we use the same calibration stick. So we just delete these dots and repeat the process. Okay, right click in red dot and clear steps. And make sure that track control is on or active. And we are ready to track again for the data trial 2. Yeah. Okay, press shift button and click the center of the ball. Click again, follow the motion of the ball. Okay, I think done, yeah. So this is our data t versus velocity in y-axis. So right click, just copy as formatted to Microsoft Excel for trial 2. Okay, we only copy the velocity and paste in trial 2. And we delete data. Okay, for trial number 3, we repeat again with the same process, yeah, same steps. Okay, don't forget to delete the previous dots, clear steps, right click and clear steps. Okay, we repeat again, make sure that the track control is active and press shift and click at the center of the ball, follow the motion of the ball. So this is for trial number 3. Yeah? Okay, I think we are done. So this is our data. We only need the data of the velocity. So just copy this one as formatted and just paste in this area and then copy again. We put in the trial number 3. Okay, so we are done with tracking process and we already get the data. So for trial number 4 and number 5, you try at home, yeah. Okay, the next step that we are going to do is the calculating the average from trial 1, trial 2, and trial 3. Okay, for trial number 4 and number 5, you do at home. The next step that we are going to do is to calculate the average or mean of the velocity. So to calculate in Microsoft Excel, just type equals average, press tab, and just select the data, click enter, and double click in this point. So we already get the average of the data or the mean of the data from the velocity. And then for the uncertainty, we use the equation maximum from this data minus minimum from this data divided by 2. So equals max this data minus minimum from this data and divided by 2. And just double click in the corner of this cell and we already get the mean v uncertainty. So this is uncertainty for this data. So this is the uncertainty for this is uncertainty for this, uncertainty for this, and so on. Yeah, I think we are done. So to plot the data, we only need the data of time and also v. We don't need to make this square or square root. So just copy the data of time and also the velocity over here. So it will make us easy to create the graph. So this one is t and this one is velocity v. This is x for x-axis. This is for y-axis. X and y-axis. So this is time. So just copy paste to this area. And also this one. And also period. Okay. To graph this data, we select all of them and go to insert, click scatter chart and choose the first one. Okay. To measure the gradient of this, we click plus. We checklist trend line and click for more option. And choose the linear one. And we checklist display equation on chart. And also R square. So we get the gradient over here. The value of the gradient is minus 11.764. We can also add the error bar over here, but we have to find the value of the error bar. The value of the error bar for y-axis can be the maximum from this value, and the maximum from this value, I think it is 0.9. Sorry, 0.99. So we highlight this one. So this is the error bar. To add error bar, click plus and checklist error bar. So in the graph, we have the error bar of x-axis and y-axis. For this one, we only need the error bar in y-axis. So this is so we delete this one. Sorry, I think I have to make it big. Okay, for this one, the horizontal one is the bar of error for x-axis, and this one, the vertical one, is the error bar for y-axis. So because we only need for y-axis, so we delete the horizontal error bar, and the value of this is 0.09. So click error bar and more option. So we type manually in fixed value 0.09. Okay, 0.09 for the error bar in y-axis. Okay, to calculate the gravitational acceleration, we have to go back to the equation. So the equation is v equals to u plus g times t. And because we start from zero velocity, so u equals to 0. So the final equation is v equals to g times t. And based on the linear equation, V is y equals to m is g and x is t. So gradient is proportional directly to gravitational acceleration. And we know that the gradient from this graph is minus 11.764. So I write over here. So the gradient, the symbol is m, equals to minus 11.764, yeah. And based on the equation, the gradient is equals to g. So m equals to g equals to this one. So this is our gravitational acceleration, minus 11.764. Okay, thank you so much.